Guys, this is June and welcome to our video presentation. Last time, you have learned how to prove some theorems using a solid figure. You have learned how to prove lines and planes perpendicular to each other, oblique lines to a plane, two intersecting planes, and you know how to determine a plane. But this time, we're going to prove some theorems about parallel planes, lines and planes parallel to each other, and dihedral angles. We'll not be using solid figure, but instead we will be using our surrounding on proving those theorems. Okay? In this video, you will be learning intercepted segments, parallel lines, and parallel planes. When you say intercepted segments, if a line is intercepted by two parallel planes, the segment formed between the parallel planes is called the intercepted segments. If you say parallel planes or parallel lines, these are planes and lines that cannot intersect or cannot meet if you extend it infinitely. Okay? Okay. Going to show theorem 7, which is if two lines perpendicular to the same plane, they are parallel. So, for example, if this post here represents a line, this post cannot meet, so therefore they are parallel. But to prove that they are perpendicular to the ground, we want to show that the angle formed of this post to the ground is 90 degrees. I'm going to show theorem 8. If you look at here, this is our straight line. It is parallel to this plane, which is the floor. Then the straight line is also parallel to the intersection of this given plane, which is the floor, and another plane which passes through that intersection line. Okay, I'm going to show theorem 9, which is if two planes perpendicular to the same line, they are parallel. So here, if this plane, that ceiling represents the plane, and this floor here also represents a plane, like if there is a point of both planes which only one line is perpendicular. Why? So that is from theorem 5, right? So, for example, if this is the line which intersect at the same point of this plane, a point of this plane here, which is the floor, and another point of the ceiling, then both ceiling and floor are perpendicular to this pillar, then they are parallel. I'm going to show theorem 10, which is if a plane is parallel to two intersecting lines, then it is parallel to the plane containing this line. So, if you remember theorem 2, two intersecting lines determine a plane. So, if you look at here, if this is the plane, the floor represents the plane. So, if this is our plane, it is parallel to two intersecting lines here. Then, this floor here is parallel to the ceiling containing these intersecting lines. To show theorem 11, which is through a point that on a plane, there is only one plane parallel to that plane. So, you know what is a plane, right? A plane is a two-dimensional space which has no thickness or weight. So, another characteristic of a plane is that it is a collection of points in a space. So, for example, if that bulb here represents a point on a plane, and this floor represents also a plane, there is only one plane containing that point here is parallel to this floor. Okay, I'm going to show theorem 12, which is through one of two skew lines, there is only one plane that is parallel to the other line. So you know what skew lines are, right? So these are lines that do not intersect, not parallel, and do not lie in the same plane. So for example, if this pillar here represents a line, this pillar represents a line, and the other line would be this one here. But this line is contain this whole plane, also this line. However, this line of this wall is parallel to this pillar, so therefore, there's only one plane which is represented by this wall that is parallel to the pillar. Okay, I'm going to show theorem 13, which is to a point outside of two non-parallel lines. There is one and only one plane parallel to both lines. So, for example, if this is our one of two non-parallel lines is here, and the other line would be this line here. There is just another point outside of those lines, which would be here. This thing would represent a point on the plane, which is here. Then the whole plane containing this point here is parallel to both lines. So, for example, if that pillar there is containing this plane here, it is parallel to this pillar, and the whole wall is parallel to that line. Before I'm going to show theorem 14, you know how to determine a plane and planes parallel to each other. So, for example, if two planes are parallel, then they cannot meet. So, in theorem 14, we have to prove that the plane containing two intersecting lines are parallel, and the corresponding angles of those intersecting lines are equal. So, for example, if these intersecting lines here is parallel to these two intersecting lines, then the plane containing those intersecting lines are also parallel, which is this floor and this ceiling here. But to prove if their corresponding angles are equal, we have to measure their degree angles. Okay, going to show theorem 15, which is about proportionality. If two straight lines are cut by three parallel planes, the intersected segments of the other line is proportional to the corresponding intersected segments of the other. So, for us to show that the intersected segments are equally proportional to the other, we have to measure the lengths of the intersected segments. So, check it out. So, in theorem 15, to show that the intersected segments, for example, if this say line here and this line here is intercepted by this multiple planes, the segments formed between the planes are proportional or equally proportional. So, to show that, we have to measure those segments. Wait a minute, Mr. Postman. Oh, yay. So, most likely, the measure between the segments between planes are 3.5 inches. So, therefore, the intercept segments between the two lines cut by three parallel planes are equally proportional. Okay, what is the header angle? The header angle is an angle formed by two intersecting planes. So, for example, if this is a plane 1, this wall, and the other plane is this wall here, they intersect at this line here, which is here. And then, the angle formed between these two planes is called a dihedral angle. A dihedral angle can be acute, obtuse, or right angle depending on the magnitude of the intersection of the two planes. Theorem 16. Two dihedral angles are equal if plane angles are equal. Then this, you know that dihedral angles are two planes meeting at straight line. So this dihedral angle here, and there's another dihedral angle here. Then this another dihedral angle, and the angle of this dihedral angle are equal to this dihedral angle. So
plane angle of this general angle are equal. Theorem 17. If a two planes is mutually perpendicular, and if a line is drawn from a point in one perpendicular to each of their intersection, then this line is perpendicular to the second plane. This pillar here is considered as a plane, and the floor is considered as a plane. Then we have noticed that we have a point here. Then we know that a line is composed of 2 points. So we can determine a line of this point of intersection of these 2 planes. So this line intersect at this line of intersection of these 2 planes. So this line is also perpendicular to the plane. Theorem 18. If a plane is perpendicular to each of 2 planes, it is perpendicular to the line of intersection. This pillar here is considered as a plane, and this another plane here is the wall, and this floor, and then this wall, and this plane and this plane is perpendicular to the floor. But these 2 planes and this plane intersect at this line, then we can conclude that this straight line, which is the intersection of these 2 planes, is also perpendicular to the floor.
Let's go! G-Dragon, feature Missy rapping, and I'm snapping, and I get it cracking when I'm in the booth, I'm blacking. Y'all just yapping, we just laughing. I got hits like a tennis racket. Big bang, clap it, in another bracket. Racks on racking, if the track is hot, then miss it, smash it. Party crash it, tragic, bust it like a prophylactic tactics. Man, this ain't no practice, copycat, you swagger jacket. Who are me? It's Missy Elliott. E to the L to the I to the O to